Now, in addition to the activities and objects that occur inside of our domain, there are certain abstractions that we leverage as well when building using domain-driven design. These abstractions can be useful for a number of different reasons. So one of the abstractions that we use is what we call a service. We talked about the fact that we have entities and value objects, and that those entities and value objects can contain business logic as well as state. But sometimes you get cases where there's a particular piece of business logic that doesn't really fit into an entity or a value object. For whatever reason, you can't come up with an entity that makes sense for that particular piece of business logic. In that case, this can be encapsulated by a service. Now, services have some special criteria. The first is they should be stateless. If you find yourself including state in it, it's not a service anymore. It's either an entity or a value object. So they should be stateless. Now, the other thing is that services are often used to abstract away something like an anti-corruption layer. So in our example here, we have our abstract email sender. Now, that doesn't contain any state. The state would be contained in an email object of some kind. The job of the email sender is just to take that email and send it. And so what we are doing in this case is we're creating an abstract email sender, and then there will be a concrete implementation, in this case an SMTP email sender. So that SMTP email sender is an external service, so we're putting an anti-corruption layer on top of it so that we're not communicating directly with it in our domain. That means that our domain doesn't need to know about SMTP. All it needs to know about is emails, which makes sense because later on we might start out using an SMTP email sender, but then later on we might change that up to something different. We might use a web service or something like that instead. So this allows us to swap in those different implementations. And again, that email sender is totally stateless, but it does contain some valuable business logic. Now, it's important to note that creating systems that use too many services leads to an anemic domain. So when we start finding ourselves in a situation where we need to implement a service, we should be very careful first at making sure that we're not missing an entity or a value object. What we don't want is we don't want services to be doing all the work. We want services to typically be fairly thin layers over a very specific piece of business logic, rather than something that just does everything. Some other examples of things you might do inside of a service. So we have the email sender. That's one example. Something like maybe if you need to hash a password at some point, then you might have a password hashing service. Your password hashing service is potentially stateless, but it doesn't necessarily really belong in any of your entities or value objects. I suppose you could put it inside of your password itself, although at the same time it would be nice to do an abstraction of some kind so that you can swap out different hashing algorithms if necessary. So in that respect, something like that would make a good use of a service as well. Another type of abstraction that we use is a factory. So when we go to create a new domain object, often entities or aggregate roots, the logic to construct those domain objects may not be trivial. There may be a lot of work involved with creating that domain object. It may have to access external resources. So for example, when we create a new reservation, maybe we need to assign a unique identifier to it, and maybe that requires us going to the database and looking at a table. So there may be, database access. We might have to look at files or REST APIs. There's all sorts of complexity that may come along with building that new object. So a factory allows us to abstract away that logic. It's, again, usually implemented as a domain interface with one or more concrete implementations. So in this case, we have a reservation factory, which knows about reservations and knows that it has a method that will allow you to create them. But it doesn't necessarily know the details of how it gets created. We leave that to the concrete implementation, in this case, the Cassandra reservation factory. So we may go to Cassandra and look in a table in order to generate an ID or whatever needs to happen. That logic is going to exist in the concrete implementation. So the factory is giving us an abstraction away from that concrete implementation, which means that our domain doesn't need to know about Cassandra. all it needs to know about is reservations. And again, that's a valuable abstraction. Factories, incidentally, if you're used to the term CRUD, create, read, update, delete, factories are the C in CRUD. They are the create. Now, repositories are similar to factories, but instead of abstracting away creation, they abstract away the retrieving of existing objects. So factories are used to get new objects. Repositories are used to get or modify existing objects. Again, if we use the CRUD terminology, create, read, update, and delete, then repositories are the RUD. They are the read, the update, and the delete. They are They often operate, again, as abstraction layers over top of databases, but they can also work with files, REST APIs, etc. So in our example here, we have our reservation repository, and we have a specific implementation of it that is file-based. So we're not using a database in this case, we're using a file system. Now, that's an important distinction here, which is the fact that oftentimes repositories are thought of as just a layer on top of a database. And while they often are, they don't have to be a layer on top of the database. The other thing is that with repositories and factories and even services, because we have this abstraction layer, we can substitute different implementations. A common thing that I will do is I'll build a repository and I will have, for example, a Cassandra version and an in-memory version. The in-memory version I'll use in tests, but then the Cassandra version I will use in production. Or I've also used this in cases where I've had a MongoDB version, for example, which then later on we swapped in a SQL version for, we actually wanted to change the database that we were using. And so you can swap in different implementations as required. Quick note on factories and repositories. So factories and repositories are related. We talked about the fact that factories are the C in CRUD and repositories are the RUD. Because they're so closely related, oftentimes people just combine them and you end up with a repository that has all of the create, read, update, and delete operations, and we don't bother with factories in that case. Tools like Akka and Logem are really powerful because they provide facilities that abstract away the need for repositories. So when you're using Akka persistent actors or Logem persistent entities, you don't need repositories or factories anymore. That's taken care of by the framework. The implementation of repositories in Akka or Logem actually ends up being done by plugins. So rather than having to go ahead and implement that repository, you just drop in a new plugin and it just works. So that's a very powerful thing. And so oftentimes when you see systems built using Akka or Logem, you will often see that they don't bother with repositories. Having said that, repositories are still a very valuable technique that I would encourage you to get a good handle on, even if you are planning to use tools like Akka or Logem.